ensuring long-term investment protection and future readiness. The second criteria is energy efficiency, which means that cable systems should be designed and operated to minimize energy use and CO2 emissions. The third criteria is reuse and recycling, defined to maximize reuse of existing cabling by making capacity, connectivity, and utilization clearly visible. And the fourth one is efficient resource use, which is defined to minimize resource waste in the design and operation of cabling systems to conserve both materials and energy. Next, let's examine several practical use cases to illustrate how imVision system can deliver measurable outcomes aligned with this key sustainability criteria. Use case 1 demonstrates energy reduction through consolidation of network switches by maximizing switch port utilization on existing switches to reduce number of powered switches per telecommunication room, to reduce power usage and to eliminate purchase of unnecessary switches. This use case aligns with the energy efficiency and efficient resource use criteria. System Manager 10.0 introduces sustainability indicators as part of the standard dashboards. That includes energy optimization gauge based on consolidation of copper switches. This gauge tracks the total number of managed copper switches at the site, along with their estimated power consumption. Power estimates are calculated using maximum power consumption values published by each switch vendor for the corresponding switch models. Switch port utilization is derived from link status data gathered using SNMP and analyzed at the equipment room level. A special algorithm evaluates switches with the lowest port utilization and determines whether the active connections can be distributed to other switches within the same equipment room. The algorithm ensures that after consolidation, port utilization on destination switches does not exceed 80%, maintaining operational resilience. The gauge displays the total number of candidate switches for port consolidation across the entire site and calculates the potential energy savings associated with powering down the candidate switches. This slide illustrates an installation practice commonly referred to as flood patching, which often leads to inefficient energy consumption. In flood patching arrangement, every panel port cabled to room outlets is pre-patched to a switch port. As a result, patch panels and switches are typically installed in alternating pattern within each rack to enable one-to-one patching of switch and panel ports with short patch cords. Some IT organizations deploy this arrangement to eliminate the task of administering patch connections to increase IT department efficiency. This approach often results in having large number of idle switch ports. This means that many switches remain powered while supporting only a small number of active connections, leading to significant and unnecessary energy waste. Traditionally, labels are attached to both ends of patch cord. Whenever a new connection is added, if a patch cord is later reused for a different connection, the existing labels must be removed and the new labels will have to be created, printed, and attached to this patch cord. As a result, over its life cycle, a single patch cord may require multiple sets of labels. Use case 2 demonstrates the reduction of material waste and energy consumption through elimination of paper or plastic labels on patch cords. This case reflects the energy efficiency and efficient resource use criteria. This use case is enabled by electronic label feature in imVision, which eliminates the need for physical paper or plastic labels on patch cords. Instead, Information typically shown on cord labels is displayed electronically on a controller screen. This information is sourced directly from System Manager and always reflects the most up-to-date connection details for each port on intelligent panels. A new energy optimization gauge, part of the Sustainability Indicators dashboard, is dedicated to tracking energy and efficiency savings achieved through this capability. The gauge monitors the total number of labels that could be eliminated on copper and fiber patch cords connected to intelligent panel ports. Calculations are based on standard paper label size of 109 by 12.5 millimeters, its corresponding material weight, and a reference energy value required to produce paper of that size. This methodology is then used to estimate potential energy savings resulting from the elimination of all labels on patch cords that are connected to intelligent panel ports. In addition, the gauge tracks time savings associated with eliminating the need to print and physically attach labels to patch cords. The bar chart within this gauge illustrates ongoing energy savings over a 1-year period, based on eliminating of new labels usage whenever the new patch connections are added to the intelligent patch panels. Use case 3 is based on imVision's ability to identify and recover stranded circuits and stranded equipment ports to maximize utilization of the existing cabling segments and reducing the need for installing new cables. As a result, it contributes to lower energy consumption and reduced CO2 emissions across the full life cycle of cabling infrastructure, including the production, installation, and operational use of both fiber optic and copper communication cables. This use case aligns with the reuse and recycling and efficient resource use sustainability criteria. The optimization indicators were introduced in System Manager 9.10, and they track the number and location of stranded circuits defined as patched cabling segments with no connections to any network equipment. Stranded switch ports, meaning switch ports connected to cabling segments but not connected to end devices, and stranded server ports, which are patched to cabling segments but not connected to switch ports. This information enables organizations to track, identify, and recover stranded cabling and IT equipment assets, facilitating their reuse while reducing waste and improving overall infrastructure efficiency. Use case 4 demonstrates how imVision remote monitoring administration capabilities can help reduce CO2 emissions by minimizing the number of trips to remote sites that do not have dedicated on-site personnel. Fewer site visits are required for troubleshooting or the implementation of cabling connectivity changes by IT. This use case aligns with efficient resource use criteria. imVision enables this capability through a range of remote monitoring and administration features, including the ability to remotely monitor unplanned connectivity changes through real-time event notifications, the ability to visually guide on-site personnel in accurately implementing connectivity changes by using electronic work orders to minimize errors, and the ability to remotely interact with imVision hardware using the virtual display feature, which is introduced in System Manager 10.0. We interviewed several partners and customers who use imVision at remote sites without on-site support. By leveraging imVision's remote monitoring capabilities, these customers were able to reduce the number of trips, often referred to as truck rolls, that were previously required to support their remote locations. On average, customers were able to reduce annual travel to remote sites by approximately 516 kilometers, resulting in reduction of 0.13 metric tons of CO2 emissions per customer per year. Starting with System Manager 10.0, customers with remote sites can further reduce the need for on-site visits by utilizing the virtual display feature to remotely address hardware and system-related tasks. Based on the 4 reviewed use cases, it is very clear that imVision system complies with the new ISO IEC 14763-5 cabling system sustainability standard. In addition to new sustainability indicators, we also added new circuit configurations dashboard to the set of standard dashboards. The new dashboard consists of 3 gauges: copper circuit configurations, fiber circuit configurations, and outside plant fiber circuit configurations. And each gauge contains 2 charts. The bar chart displays the list of all end-to-end circuit configurations grouped by number of segments per circuit. The second chart is the time plot that shows number of end-to-end circuits added or removed per month. This new dashboard is designed to provide users with visibility into the total number of end-to-end circuits managed by the imVision system for a given site. It also offers insight into various circuit configurations that have been deployed, making it easy to identify configurations that may not comply with design requirements, such as exceeding the maximum allowed number of connections. Additionally, the dashboard enables straightforward tracking of circuit creation and circuit decommissioning activities over time. And now is the time for the first polling question. So we just discussed about the new ability to show how the number of underutilized switches can be consolidated into fewer switches to further reduce the energy usage at the site. So we'd like to get your feedback about this feature by asking the questions: would you be interested in having System Manager automatically identify candidate switches for consolidation and generate work orders for implementing the consolidation? Okay. So you have about 25 seconds to select your options. Let's look at your results. Many of you are interested in getting both capabilities, okay? Our results are being updated in real time. So, but majority do like this option. So we definitely will consider adding this option in future release of System Manager. So thank you very much for your feedback. We also implemented several enhancements to SNMP feature in 10.0. And many of you may recall that a year ago, we introduced support for SHA-256 cryptographic hash function in System Manager 9.10 Service Pack 1, which strengthens SNMP v3 security through improved authentication. More recently, we have learned that several switch vendors are now enforcing the use of SHA-512. This is driven by a combination of factors, including enhanced security requirements, evolving compliance obligations, platform modernization, and long-term risk reduction. Part of the compliance obligations includes the European Union's mandatory NIS2 directive, which requires the use of state-of-the-art cryptography in this demonstrable risk reduction. As a result, supporting SHA-512 by default helps simplify certification efforts, audit readiness, and market access across European Union. For these reasons, we have decided to add support for SHA-512 in System Manager 10.0. Several customers and partners have requested adding the ability to discover power outlets via SNMP when the capability is supported by managed power strips. System Manager 10.0 introduces enhanced SNMP support that enables discovery of individual power outlets and automatically adding them to the corresponding managed power strips. Once displayed in System Manager, each discovered power outlet is shown with a power status icon, a green icon indicating that the outlet is actually providing power, or a yellow icon indicating that the outlet is in idle state. Power connectivity option supports adding connections between discovered power outlets and power input ports on switches and servers via a cabling option in the same manner as it's done today for manually created power outlets. When supported by managed power strips, System Manager can periodically collect and track per outlet power usage data via SNMP. The following power usage metrics are populated in dedicated fields within the properties of each individual power outlet. We show current power usage in watts, average daily power usage in watts, average daily energy consumption in kilowatt hours. In the last segment, we will share several updates about upcoming features in System Manager 10.1 and firmware version X.5.1. Let's start by introducing a new feature in System Manager 10.1 that further enhances visualization of connectivity data. Most of you are familiar with the option to display the outside plant trace on the geomap by highlighting the conduit paths between two connected locations. To enable this option, a user must select a conduit segment in the trace window. The example shown on the slide illustrates the trace between the 2800 Telecom Parkway building and the 2601 Telecom Parkway building. It highlights two conduits shown in green and orange, representing the connectivity path between the two locations. In System Manager 10.1, we are extending this capability to support traces within the building on a floor plan. From the trace window, users can select Show Trace in Spaces icon to draw a line on the floor plan that connects all connecting nodes in a selected trace that are present on the floor plan. Each connecting node is identified with a solid circle. In the example shown on the slide, the trace connects a switch port to an access point and consists of 5 connection segments. Segment 1 and Segment 2 connect the switch and patch panel ports installed in equipment racks. Segment 3 represents a cable connection between the patch panel port and the port on the consolidation point. Segment 4 represents a cable connection between consolidation point and outlet on a faceplate. And Segment 5 is a patch connection between an outlet and the end device. This segment is not shown with a segment line because in this example, the end device is represented by automatically placed device badge positioned next to the faceplate. On this slide, we show how the Trace in Spaces feature works in a data center environment. The trace window is showing a circuit between the spine and leaf switches. It consists of 3 connectivity segments. Segment 1 is patching connection between the switch port in cabinet 1 to patch panel in cabinet 2 in row 1. Segment 2 is cabling connection between the panel in the cabinet 2 in row 1 and the second panel in cabinet 1 in row 3. Segment 3 is a patch connection between the panel and the switch port in cabinet 1 in row 3. Because the panel and the switch ports are in the same cabinet, this segment is represented as a hollow circle. The adoption of wildcard certificates in imVision addresses concrete needs expressed by customers regarding certificate management efficiency and operational simplifications when using HTTPS on imVision Controller X. The need for more efficient implementation of HTTPS across multiple Controller X zones became increasingly important with the introduction of the virtual display feature in System Manager 10.0. A quick recap: the virtual display feature uses the embedded iframe to load the child page virtual display within the System Manager pop-out window, which is a parent page. Modern web browsers enforce strict security policies, including mixed content blocking, which prevents HTTPS-based System Manager pages from loading HTTP content from the imVision zone within the same window. Therefore, based on this rule, users need to enable HTTPS in 2 out of 3 possible configurations that supports virtual display feature as shown on this slide. A wildcard certificate is a digital certificate that uses an asterisk in its domain name. This single certificate allows to secure multiple subdomains without needing to create or manage separate certificates for each host. This model aligns with the best practices used in enterprise infrastructures, where wildcard certificates are commonly employed to streamline device onboarding. The benefits of using wildcard certificates are simplified certificate management, reduced operational latency, enhanced security and compliance, and improved maintainability. Starting with X.5.1 firmware, the imVision Controllers X will be able to import and use wildcard TLS/SSL certificates to secure HTTPS access. This will enable the use of certificates issued by Enterprise Internal Certificate Authority, Public Certificate Authority, and Self-Signed Wildcard Certificate Authority. The new functionality allows administrators to directly import their wildcard certificates and private key into imVision, enabling immediate activation of HTTPS encryption without per-device certificate signing request generation. And the second polling question is we want to find out whether you are using HTTP or HTTPS for imVision zones that contain only Controller X. You have 25 seconds to respond to this polling question. Let's see how you are doing. All right, so far, most of you are using HTTP. Few of you using HTTPS. And let's see, so far we have about 27 people responding. Okay, we have 30 responses now. Still majority of you using HTTP? Okay. Very good. Well, I do appreciate your feedback, and hopefully by installing 10.1 with the X.5.1 firmware, those of you who currently use HTTP will be able to switch to HTTPS because of the ease of enabling HTTPS with X.5.1 firmware. Okay. So thank you very much for your feedback. Okay. Okay, so as we conclude this webinar, I would like to take this moment to highlight a special milestone. On April 1st, we celebrated the 25th anniversary of imVision system. Over that time, imVision has been deployed by customers in 65 countries with more than 27 million intelligent ports installed, including several deployments exceeding 600,000 intelligent ports. We are also proud to have a number of customers who have been using imVision system for over 20 years. I would like to sincerely thank all of you for being part of this remarkable journey and for your continued trust and partnership over the years. Okay, so now for the certified imVision specialists, please get ready to complete the assessment test. And as we always do, to access the site with assessment tests, simply open Handouts tab and select the redirect link for testing. Also, the Handouts tab contains the release notes for the latest System Manager 10.0 for your convenience. If you submitted any questions, I'll be happy to respond to you via email. And thank you very much for your participation. And until next time, goodbye.
"20 years ago, enterprise networks were just beginning to be recognized as a strategic competitive asset. As they grew more critical, they also grew more complex, and management of the physical infrastructure with manually updated spreadsheets or even sophisticated cable management software was found to be prone to error and frankly inadequate. So in 2001, CommScope introduced iPatch. With individual port sensors, an iPatch rack manager, and system manager software, the iPad system was able to automatically document moves, adds, and changes, thereby enabling IT teams to work faster and more accurately. As the iPad's adoption grew, so did its functionality, but the real breakthrough came in the year 2005 with the introduction of network device discovery. This provided an unprecedented level of visibility into the network, from the physical layer connectivity to the connected devices. As we continued adding functionality to the system manager software based on customer feedback and network evolution, it gradually redefined infrastructure management. That was the start of imVision. With the introduction of imVision, CommScope also initiated standards development activities to define AIM, Automated Infrastructure Management, in order to move away from the disparate silos of incompatible proprietary systems and into an interoperable environment. Since 2001, iPads and imVision have helped manage some of the world's most complex networks. As impressive as the past has been, wait till you see what's in store for tomorrow. 20 years ago, enterprise networks were just beginning to be recognized as a strategic competitive asset. As they grew more critical, they also grew more complex, and management of the physical infrastructure with manually updated spreadsheets or even sophisticated cable management software was found to be prone to error and frankly inadequate. So in 2001, CommScope introduced iPatch. With individual port sensors, an iPatch rack manager, and system manager software, the iPatch system was able to automatically document moves, adds, and changes, thereby enabling IT teams to work faster and more accurately. As the iPatch adoption grew, so did its functionality, but the real breakthrough came in the year 2005 with the introduction of network device discovery. This provided an unprecedented level of visibility into the network, from the physical layer connectivity to the connected devices. As we continued adding functionality to the system manager software based on customer feedback and network evolution, it gradually redefined infrastructure management. That was the start of imVision. With the introduction of imVision, CommScope also initiated standards development activities to define AIM, Automated Infrastructure Management, in order to move away from the disparate silos of incompatible proprietary systems and into an interoperable environment. Since 2001, iPatch and imVision have helped manage some of the world's most complex networks. As impressive as the past has been, wait till you see what's in store for tomorrow. "20 years ago, enterprise networks were just beginning to be recognized as a strategic competitive asset. As they grew more critical, they also grew more complex, and management of the physical infrastructure with manually updated spreadsheets or even sophisticated cable management software was found to be prone to error and frankly inadequate. So in 2001, CommScope introduced iPatch. With individual port sensors, an iPatch rack manager, and system manager software, the iPatch system was able to automatically document moves, adds, and changes, thereby enabling IT teams to work faster and more accurately. As the iPatch adoption grew, so did its functionality, but the real breakthrough came in the year 2005 with the introduction of network device discovery. This provided an unprecedented level of visibility into the network, from the physical layer connectivity to the connected devices. As we continued adding functionality to the system manager software based on customer feedback and network evolution, it gradually redefined infrastructure management. That was the start of imVision. With the introduction of imVision, CommScope also initiated standards development activities to define AIM, Automated Infrastructure Management, in order to move away from the disparate silos of incompatible proprietary systems and into an interoperable environment. Since 2001, iPatch and imVision have helped manage some of the world's most complex networks. As impressive as the past has been, wait till you see what's in store for tomorrow.
The last 20 years has been a continual process of adaptation and innovation for imVision. Each new feature is a response to the changing needs of CommScope's customers. Today, those needs reflect the growing complexity in customer networks. Spine leaf architectures have become the norm inside the data center. imVision helps IT teams document and manage the surge in fiber array connectivity, polarity, and MPO port configurations. Inside smart buildings, imVision supports IP convergence. It can track new devices and monitor PoE distribution over the structured cabling system. This helps to make sure the cabling is operating within the desired operational conditions. Across smart campuses, imVision consolidates all documentation for outside and inside plant cabling to give a single source of truth. It can track individual fiber strand connectivity through the campus using geo-coordinates to pinpoint the exact location of every connecting point on GeoMap. CommScope is more committed to imVision than ever. With over 90 automated infrastructure management related patents, 3 new update releases annually, and over 25 million intelligent ports across 65 countries, we're just getting started. Stay tuned to see how CommScope and imVision can take you from then to now to next.
Hello everyone. As we celebrate imVision's 20-year anniversary, I want to take a look now towards the future. In the future, building campus and data center networks are going to get smarter, and so is imVision. Tomorrow's imVision will look more like an IoT-based solution, more self-aware, easily discovering and onboarding new connections and applications and devices. As network activity moves to the edge, imVision will enable remote monitoring and administration for lights-out edge data centers. Imagine managing infrastructure from anywhere to anywhere using AR glasses and applications, or using digital twins to manage and optimize your physical environment. That is the future of imVision. As it develops alongside CommScope's other next-generation products, imVision will be more accessible with cloud-based solutions and subscription-based models designed to increase your flexibility, value, and return on network investment. After 20 years of constant innovation, experience, and customer feedback, imVision remains the gold standard for automated infrastructure management, and that will not change. Each time CommScope raises the bar, our customers get better. Better infrastructure, better management, and better vision.